Smart devices and the Internet of Things are increasingly becoming more integrated into people's spaces and environments. However, to control these devices, existing solutions constrain the user to their mobile phone scrolling through lists and opening separate apps. Although smart speaker systems attempt to unify this ecosystem through voice commands, these interactions have limited expressivity, especially when dealing with a large number of spatially distributed devices. Building off of the classic put that their system, we contribute an exploration of the designed space of voice plus gesture interaction with spatially distributed IoT devices. Our design space decomposes users' IoT commands into two components: selection and interaction, where each component can be manifested as voice or gesture, or sometimes a combination of both. We detail the design space in the paper and use this video to demonstrate a proof of concept sensing platform and example interaction scenarios. Our system integrated off-the-shelf UWB modules and IMU sensors to register IoT devices' spatial configurations, detect users' freehand gesture in combination with voice commands. We implemented several example applications, some of which intentionally expands and stretches the system's core idea to demonstrate its applicability to other familiar HCI scenarios. First of all, our system allows user to control appliances by their choice of modality in terms of different contextual situations.
Turn this light on.
In this scenario, the user used a verbal command to turn on a light, and choose to perform a silent swipe down gesture to turn it off at night time. Also, the system endows the user's verbal commands with contextual information.
Turn off the lights here. Turn on the lights here.
Our system also allows the user to interact with multiple devices at the same time.
Turn on this, this, and this.
When a pointing selection is ambiguous, the system allows for verbal or gestural disambiguation.
Turn off the bat.
Naming devices and zone registration are also being supported in the system.
Name it as silver. Turn on silver. Register the video. Turn on the living room lights.
Furthermore, user can provide indicating information for the appliance.
Turn this off.
Also, the user can adjust the appliance's status by continuous gestures plus voice commands.
Modern.
Every time I go to sleep.
In this scenario, the presenter authorized the projector to access his personal slides, which can be controlled by gestures. As an audience member raises his hand to ask a question, the presenter points at him as an acknowledgement for authorizing him to control the slides. Besides those, user can interact with the predefined physical object which doesn't have any circuit on it.
Waking up at 7.
In this scenario, the user pointed and commanded the nightstand, which is predefined as a multimodal alarm, to wake him up. And later, he used a silent down swipe gesture to stop the alarm. To summarize, we contribute an exploration of the designed space of voice and gesture interaction with spatially distributed IoT devices. demonstrated in various example interaction scenarios in this video. Please refer to our paper for details about the design space.